Hey guys, this is Fozon, and in today's lesson, we're going to be discussing arrays. Our lesson objectives: learn how to create an array, and then we're going to learn how to initialize arrays with objects. So to understand arrays, we need to understand why it's necessary to have arrays. So if a teacher rather has a bunch of students and she wants to store her students' scores, test scores, final exam scores, or whatnot within a computer, it would be impractical to create a variable for each and every student and then access these students via their own identifier, right? Because it's not only not organized, but also it would be a big hassle for the teacher to manage. This is where arrays come in. An array is a group of variables of the same type that are accessed through the same identifier and their object or location within the group. So think of an array as a one row table, and each column represents a certain element. So if a teacher has an array of students, then each column would represent one student, and then the row would represent all the students in the array. It's important to note, just like other elements within computer science or other data structures within computer science, the index of the array starts at 0. So when we access the first element of an array, we call it by position 0. And if you want to access the last element of the array, we would have to access it by the number of elements minus 1, or n minus 1. And this allows us, these arrays allow us to store a multitude of values within one identifier. So we could store 428 integers and then access it by the same identifier and then a different position value respective of where they are located. We could also store 70 bank accounts and 330 students, and these numbers are subject to change to whatever you want necessary. So the initialization of an array mimics the way that we declare and assign a variable. We could do int, then we have the brackets that emphasize that we want an array. This separates it from, hey, we want to declare an integer, to, hey, we want to declare an integer array. Equal to new int, and then within the brackets we have the number of elements that we want, the number of elements. So in this array declaration, I want 10 elements. This is subject to change to whatever value you want necessary, or the number of elements you want in an array. We could also put the brackets after the identifier, but more likely you're going to put it after the data type. You could also declare the array, and then you can create the array through a separate Java statement, but most likely, again, you're going to be using this statement. This statement is usually easiest to memorize. So when we create an array, we can also change the elements as well by accessing the identifier and then the respective position within the array. So we have an integer array declaration, and then we create the array of 3 elements. So this integer array is going to contain 3 elements. And to access the elements of the array, we start at 0. So the first element is going to have a position of 0, the second element is going to have a position of 1, and the third element is going to have a position of 2. And the way that we access these values is by the identifier. So this is depends on the context of your array. So if you're storing integers, well, I named it my ints. But if you're storing, like, say, test scores, then you would do test scores as your identifier. But in this case, I have my ints. So we access it through the identifier, their respective position. So open bracket, their position. And then since I'm assigning a value to that position, I use the assignment operator, and then I store the value. So at position 0, I'm going to have 1. At position 1, I'm going to have the value 2. And at position 2, I'm going to have the value 3. This is the result array. We have position 0, position 1, and position 2. Values 1, 2, and 3. And if I tell the compiler to print out position 1's value, and we access it by the identifier, and then a bracket that has the position that we want, it's going to print out position 1. So position 0 is 1, and then position 1 is going to be 2. And it prints out 2. 0, 1, 2. We could also initialize an array via an initialization list rather than having 3 Java statements that initialize every single array element. So in this case, I have a declaration for an integer array, Then I tell the compiler that I want to create an array, and I omit you don't have to include the number of elements that you want, because the computer can determine can determine it itself simply by the number of elements that you put within our initialization list. And you create the initialization list by putting the curly brackets after the int bracket statement, and then you separate the elements that you want to include within the array with commas. And this is just like the previous example, where the first element is going to be position 0, and the last element is going to be the number of elements minus 1. So since there's 3 elements, the last position is going to be 2. But in this case, I'm trying to access position 1, and well, position 1 has the value 2, so it's going to print out 2. Here's an example of me changing a value within initialization statements. So we have an integer array, and then we set the values to 1, 2, and 3. So we have an array that has has 1 at position 0, 2 at position 1, and 3 at position 2. And I want to change the value at position 1. So if I change the value at position 1, we're going to when we print it out, it's going to be the newly assigned value. In this case, it's going to be 5, since I assigned 5 to our new position 1 value within our integer array. Now we have this thing called automatic initialization, meaning that when you declare an array of values, they're going to have an automatic value already stored there. Think of every element as you declaring a value, or you declaring a variable. And the variable identifier is not going to be one that you create. It's just going to be the name of the array, or the identifier of the array, and then the position of every single element. And in the case of integers, or rather primitive types, they have their own respective automatic initialization values. But in terms of objects and strings, because strings are, well, objects, because they are the string class, they will be automatically set to null. So if I initialize an integer array without an initialization list, if I access the last element of our array, it's going to print out 0. So for an integer array, it's automatically set to 0 if we don't change the values. For a double array, it's going to be 0.0. For a Boolean array, it's going to be false. And as you can see, it still follows the same format. So I have a Boolean primitive type, and then just like my integer array, we're going to just simply put the brackets there to emphasize that we want a Boolean array. And rather than having new int, we have new Boolean, the data type that we want. For strings, again, they're objects, so it should be initialized to null. Initialize will be a misleading word. Technically speaking, you're creating or declaring a string identifier, being my string 0, my string 1, my string 2, but these don't hold any values, or they're not pointing to any memory location. So since it's null, if you recall, null means that this identifier is not pointing to any memory location, we would have to put values within our array to make sure that they're not null values. And the same thing is with objects. Now, you're most likely not going to have an object array like this, because, well, it's impractical, because objects values are not going to be that well within your algorithm. However, this just goes to show the general format. So you're going to have the class name. In this case, I put object, and then for the initialization statement, we're going to put object. And then when we access the object array, it should return null, or a value within the object array. This is more practical. So I have a bank account class, I will have bank account objects, but I never actually create the bank account objects. All I did was I created the bank account array with bank account identifiers within the array. And if we access the elements, it's going to still be null. So we would have to initialize every single value through their respective constructor. I'll show you how to do this within the compiler. Before we do anything in the compiler, let's discuss the length of an array. Once you create an array, you cannot change the length, aka the number of elements you can put in it, without deleting the original array. To access the length of an array, you type the identifier and then you put .length. and it returns it as an integer, so you can put it directly into a print statement, or you could store it as an integer and access it later. So if you want to create a new array with an old reference, this is what occurs. So I declared an array of 10 elements, and just for the purpose of showing you what actually happens when we use an old reference to create a new array, I changed the value at position 5 to, well, 5. So at position 5, it's going to have a value of 5. At the rest of the values, it's going to have a position of 0. And when I use the old identifier to create a new integer array, so again, we have the initialization, or we're constructing a new integer array. What happens when I access the 5th position, the one that I changed to 5? It's going to go back to 0 because they deleted the values and created a new array. So to get the length of an array, we could do that through 2 ways, really. I mean, I could show you through 2 ways. We have a Boolean array that is declared like so, and as you can see, the length should return 5 because within our declaration, we mentioned that we want a Boolean array of 5 values. And even if I change the first and last value to true, then it still should return 5. Remember not to put any parentheses after length because we're not accessing a method. We're accessing length of the array. In this case, rather than, well, in this example, we had it initialized through the regular way that we would use it for. But if we have an initialization list that doesn't have the length inside this brackets, the computer can determine that automatically. You don't have to worry about putting a number within these brackets. So if I declare a double array, a new double array, and I put values such as 0.69, 420.81, these type of values, the computer simply counts, right, and it knows how many values there are because we separate every single element through a comma. So we have 0, 1, 2, sorry, not 0, it doesn't start at 0, it starts at 1 when it's counting length or the number of elements. So it should be 1, 2, 3, 4. We have 4 elements. So if we access the array through the identifier and then call on its length function or whatnot, or its length, it should return the number of elements, aka 4 in this case. So let's go in the compiler and actually create these arrays. There's a lot of arrays that we want to cover in a short amount of time, so let's go. So please ignore the methods that I have here. This will simply allow us to print the array in a fashion where it's actually recognizable. So I will explain you the syntax in a much later video, and if you're interested, it's the for each video, the one that we use for loops, and this allows me to print the array in a way that it makes sense. So let me declare an integer array, and let's label it my integers. And let's create it like this, and let's have 5 elements. Now I'm going to access my print array method that I have for integer arrays, and then I'm going to put my integer array as the argument, so this should print out the integer array that we have. So we have 0, 0, 0, 0, it's automatically initialized to 0. Let me do this with every single value. So we have doubles. Let's do my doubles is equal to new double. And just for the sake of keeping everything simple, let's keep it at 3 for every single one of them. We could do Boolean as well. My Booleans, or let's do my boos is equal to new Boolean. And then let's put 3 values. We could do string. And in the case of string, it's going to be interesting because they're not primitive types, so they're not going to have an automatic initialization. They're going to be all nulls. And I'm going to put 3 elements there. And then I have a bank account class, and within the bank account class, it has 3 constructors. We can construct it through a name. It could have a automatic, well, it has a one without arguments and has one with all 3 arguments for each instance variable. We have accessor methods, we have our mutator methods as well. And I'll show you how to access these via an array identifier rather than making a bank account object and then accessing it through the bank account identifier. So this is going to count as our object array. Is equal to new bank account, and again 3 elements. So now let's print out all these values and show you how these are automatically initialized. We have 5 arrays, so we're going to print out 5 arrays. My doubles, my boos, my strings, and my accounts. And as you can see, you can see the automatic initializations of these values. So the first 3 are primitive types, so they're going to have an automatic initialization value. For integers, we have 3 elements. Well, for all of these, we have 3 elements, so you're going to see 3 elements for each of them. But for primitive types, we have different values. So for integers, we're going to have 0. For doubles, we're going to have 0.0. For Boolean values, we're going to have them set to false, and then for objects such as string or bank accounts, it's going to be automatically set to null. Let me now erase these values so that we can use them later on. To change a value within an array, it could be simply done by accessing it. My integer, I want to access something at position 0, or the first element, and I want to change it to the value 5. Let me do this for every single value within the array. Let me do my integer, and then the final, this is the last value within our array, and it's going to have a value of 7. And we know this because we have 3 elements, so to access the last element, it's going to be the number of elements minus 1. So when we print the array, it's going to be 5, 6, and 7 because that's the values that we assigned to it. We can combine this all in one statement by doing an initialization list. So let me remove the number of elements and then store it within our curly brackets. 5, 6, 7. Let me remove these Java statements because they're now unnecessary because we have it over here. And then we have 5, 6, 7. And you could change it even after you do the initialization list. Nothing is stopping us from doing it. So my integer, and then let me change something at position 2 to maybe 21. And as you can see, it makes the respective chains. So although the length cannot be changed without deleting the entire array, we can change the elements within the array as many times as we want. Now for string array, it's going to be interesting because these are objects. So we could do it in multiple ways. We could do it via, well, let me first change this to my strings. So as you can see, it's automatically initialized to null, but we can change the values via their own respective Java statements. So we access the string array, we access their position. So I'm going to access position 1. And then each string position or each string array element is going to have their own string. So let me store hello there, and then let me put friend. So if we print out our array, it's going to say hello there friend. Those are the values that we put. So now it's not pointing to a null. Now it's not a null pointer. It's not pointing to a memory location that has hello, that has there, has friend. So position 0 is pointing, has hello. Position 1 is going to have there, and then position 2 is going to have friend. And we could do it within an initialization list as well. We can have hello, we could have there, and then we could have friend. And then we can end with that curly brackets, and remove this. And as you can see, we have the same thing. Now, if you recall from our string class video, the string class is, well, misleading in that it's not a primitive type. So the instantiation that you would use or the assignment that you would use for strings will be different for other objects. Strings are ultimately objects, but you wouldn't use that assignment for every single string. So I have the bank account class, a bank account array, to help you understand this. So to actually create an array, well, we do so with our standard declaration. We have the name of the class. We have our brackets to emphasize that we want an array, our identifier, our assignment operator that creates our array, and we have 3 elements just to keep it simple. So if I were to print out this array through my method, what happens? Well, let me make sure that my method is up to date. So let me edit that just to be sure. Let me remove this. All right. So let's see what happens. These are null pointers or null values because we haven't actually created bank account objects. What the compiler knows is that within our array, we're going to have bank account objects there, but it actually hasn't created the bank account objects within every position. So it's our job to create the bank account objects. We could do so in a multitude of ways, but I'm going to show you two examples. So the first way that we can do it is through by accessing every single position and then creating the object manually. So we could do my accounts, access what location we want, and then set that equal to our constructor. So I'm going to copy this, and then I'm going to paste this, and then for every single, let me change the positions because we have 3 elements, and every single position is going to get its own constructor, or it's going to get its own object. So we have new bank account, and since this is a bank account object, we don't have the brackets. The brackets emphasize an array, but we want to create a bank account object, so we access the constructor. New bank account, new bank account. Let me do that, and let me do this. So now we've created the bank account object. So now this is not a bank account filled with empty elements or null pointers. It now actually has bank account objects within each respective location. Now the issue is that, well, when it creates the objects, every name is going to be set to null, the checking is going to be set to 0, and the saving is going to be set to, well, 0. But let's see what values we get. Well, now instead of null pointers, they're now pointing to the memory location of our objects. And as you can see, we actually have 3 objects created. Now the thing is that these objects are not really practical to have. Well, rather, us printing out these memory locations isn't practical. So in our case, we would most likely have arguments within our constructor. So to make it simple just for now, I have a constructor that has an argument of string name, and this just simply allows us to have a name set up. So the name is not going to be a null value. So I'm just going to put Fozan in here. We're going to have, let's say, Umar over here, and then we could have, let's say, Vikram in here. And as you can see, it's accessing memory locations. And this means that we don't have a toString method within our bank account class. So let's create a toString method that returns the name. It's getting the toString method from the object class, and we don't want to use the object class's toString method. So public string toString, and let me return the name. If you recall, this allows us to access it. This is the return type. This is the toString method that gets invoked whenever we want to access the object through just its identifier, and then we're returning the name of every single object. So now, instead of printing out the memory locations, it should print out the names of each bank account. So let me print this out. Let me make sure that this is saved as well. Since we're using it, and there's no error here, so it's going to override the object class's toString method. Sorry about that. And as you can see, it prints out the name values within our array. So now we actually have values within our array. If we, let's say, create a empty bank account, it's not going to have my, let me just do that for now, just to keep it simple. 3. Oh, don't put the semicolon there. Let me copy this. Let me paste that there. And let me do my second array. So there are two very different things about these arrays. One array has bank account values. This array, bank account, my accounts, this actually has bank account objects within our array. This array, my2, it knows that we want bank account objects, but there's no bank account objects located at any position within our array. So it's not pointing to any value. It's not pointing to any memory location, since we have a memory location for these objects. And that's why they're automatically set to null. Let me erase this. We have two things left to discuss. One thing is, how do we change the value of name, or how do we access it and change different values within our object? And well, the final thing is our length. So there is a way to change it. You simply just access it through the through the array name. You do the position that you want to change. So let me change position 0s. And let's change the name. So what method allows us to change the name? So we have the getName method. Okay. We have a setName method, and the setName method is simply setName with our string arguments. So it's simple, right? Rather than having an identifier, we just use the identifier of the array and the position. So set name. Oh, that's not it. And then within our string arguments, we're going to have our string. So I want to change Fozon to, let's change it to Foz. All right, so now it's no longer going to have Fozon, it's going to have Foz. And as you can see, it makes that respective change. We don't need to create a bank account object, but we can do it simply by accessing the identifier within the array and the respective position. And you could do the same with the accessor methods. So if I put this around a print statement, and then let me put get name. Let me change the arguments there. It's going to do the same. So actually, let me keep that there. And it prints out the name. So you can treat it like an object. In fact, treat it like an object. I know that it looks very different from what you're used to from the previous sections. However, when you're accessing array values or array elements, you access it like this, and then you assume that this is a bank account object. This is a bank account object. This is a bank account object, and this is a bank account objects. Together, they become a bank account array. To access the length of the array, you simply access the name of the array. So it's going to be my accounts, for example, dot length, and it should automatically do it for you if you have the compiler to do so. And it prints out 3 in this case because we have, well, 3 elements. That wraps up my video on arrays. I know that it could be tricky, and you will have to watch some parts of it multiple times to understand it. However, it becomes very easy after you recognize the different patterns. Ultimately, they are similar. If you look at the instantiation of every single array, they are pretty much the same, except for whatever data type that you're using to have within your array, because they're all the same data type. And you have to also understand is what is actually being stored when we create an array. So when we're creating an array of objects, because that's really important, if you have an array of objects, it's going to have null values. So the computer knows that you're going to store certain objects within that array. If I create a string array, it knows that it's going to be string values within the array. It's just that you haven't put string values within the array. So we do so like through an initialization statement like I have here, or we set values within the string to change it from null to our string value. Same case with bank account, except we have to understand that it doesn't follow the primitive type. So every single instantiation or every single value needs to be instantiated through a constructor. And we have that constructor whenever we access the elements. So in a bank account array, my array already knows through this initialization, by the way. So if I have an initialization like this, my computer knows that I'm going to have bank accounts within my array, but it doesn't have any values to start with, or it doesn't have any bank accounts created there. So I need to create the bank accounts at every single memory location, and that will allow me to, use use an array to store bank accounts. I want you to try this with the student class that we used in another section, and hopefully that will help you tone down the skills.